Let's take a look at this example. Given the cubic polynomial f of x equals x cubed minus x squared minus 5x squared minus 4x plus 20, answer the following. Find the x-intercepts of the function algebraically. Show how you arrived at your answer. So graphically, I could go to my calculator, type it in, and look at the x-intercept. But when they say algebraically, you have to show the math behind it. And it's important to remember that x-intercepts are the same thing as solutions. So if they're the same thing as solutions, I am going to solve this polynomial when f of x equals 0. Now remember, I have 4 terms. Whenever we have 4 terms, we factor by grouping. So I'm going to group the first 2 together. They have a GCF of x squared. I have an x minus 5 left over. The next 2 have a GCF of negative 4. I have an x minus 5 left over. So I have x minus 5, x squared minus 4. You could tee off from here, but I'm going to continue factoring because I have a difference of 2 perfect squares. So my x minus 5 stays. I'm going to break my x squared minus 4 into an x minus 2 and an x plus 2. I'm going to tee off. I have x equals 5, x equals 2, and x equals negative 2. So those are my x-intercepts. We could write them as coordinate points. And remember, they're the same thing as solutions because they are real roots. Part B says, explain why the graph below could not represent that of f of x. So I could go straight to my calculator, I could type in my equation, and I could take a look at the graph and see that they don't match. But we want to just review some key concepts with polynomials. The first thing is I have an x cubed. So this is an odd degree. So odd degrees point in opposite directions. My arrows, my end behavior of my graph. In the graph shown here, my arrows point in the same direction. So that's the first thing I'm going to write. This graph shows an even degree polynomial. But f of x is a cubic, which is an odd degree. So that's one way you could explain it. They didn't ask for multiple ways, but I do just want to talk about another possibility here. We solved in part A for all of the solutions or the x-intercepts. They don't necessarily match my graph. Now this could be, this point here could be negative 2, this point here could be 2, and this point here could be 5. It's not labeled, so I don't know. But remember your multiplicities. My multiplicities algebraically are exponents. So these all had an imaginary exponent of 1, which means they were all multiplicities of 1. So graphically, they all have representation of straight through. That's not the case here. So you could also mention that the zeros all have a multiplicity of 1, but in the graph, there's a multiplicity of 2 shown due to the bounce. So those are two options. You could always check your work by looking at your calculator, but we just wanted to make some connections between solving algebraically and taking a look at the graph.